All right, our speakers. So you probably know our next speakers. They're no stranger to DEF CON, over 10 years. Jason Haddix and Gunnar Andrews. Yeah. Jason is the CISO and hacker in charge at Buddobot. The world-class adversary emulation consultancy. He's had a distinguished 15-year career in cybersecurity previously, serving as the CISO at Ubisoft, head of trust, security, and operations at Bugcrowd, and much more. Gunnar is an offensive security enthusiast from the Midwest. He enjoys offensive tool development, fitness, adventures, and gaming. Today they're going to speak on CloudRecon, aptly named, a suite of tools for red teamers and bug hunters to find ephemeral and development assets, and to scan cloud providers for hidden gems by inspecting SSL certificates. Let's give a warm welcome to these guys.
Awesome, thank you so much. So my name is Jason, this is Gunnar, as he said, and we're gonna release a tool today. So the repo is already online on Gunnar's GitHub. It's called CloudRecon. We'll show a screenshot at the end, you can grab it. So this is us. Gunnar's picture is way better than mine, obviously. I'm surprised he wore sleeves though today. Okay, so the talk. As a red teamer, it's difficult to find an organization's apps in the cloud if they are not advertised. So this is one problem you have as a tester. Another issue is applications are often developed in the cloud while they're public on the internet. Several organizations have done this kind of thing. And then our third issue is ephemeral cloud-hosted applications are sometimes brought online temporarily to do like one thing for like an hour, and then they go offline. And often these apps are never tested for security vulnerabilities. So we're going to talk about addressing some of these issues with the tooling that we're going to release today. So this is a talk from 2018's 44Con by Shubham Shah and Michael Giannakis, and it was called Catch Me If You Can, and it was about ephemeral assets. And this is a really good talk if you haven't seen it, but this is one slide out of Shub's talk. Basically what happened is in 2017, they were looking at Slack, and they had found all of Slack's domains, right? And one was slack-reader.com. But what had happened is that they had seen this in one of their scans and never seen it again. And then they saw it months later in their scans and never saw it again. This was just subdomain enumeration they were doing all the time. And so by continually monitoring the cloud, eventually they found out that this application only went online for an hour a day. And it did some API integrations with some other servers in the cloud, and then it went offline. And so by continually scanning the internet for the certificate of slackreader.com, they were able to pinpoint when it came online, scan for that hour it was up, and they found out that it had a .git directory open to the world. So in that .git directory was about 1.6 gigs of source code and contained over 300 hard-coded secrets. So this is an example of an ephemeral asset. Comes up, goes down. There are many others in this talk. You can kind of check them out. So how do we find these ephemeral assets? Or how do we find like assets at all for a company who has stuff in the cloud? Well, we use certificates. But first we have to know where to look for the certificates. So this is an example of AWS, right? So if you go to the reachability test page, you can see they have listed all of their IP ranges, right? And this is public information. Every cloud provider has a list of every IP that they have on the internet, even the gov spaces, right? They're just required to by compliance law. And so you can go here and grab all these IP ranges. So this says, this is everything, except for you get to scroll down a little more. This is everything Amazon owns, right? So potentially every site that uses AWS should be somewhere in one of these IP ranges. So how do you find sites of your target inside of these giant ranges? Well, you look at certificates. So when someone brings a site online, obviously most of the time they use SSL HTTPS, right? And so inside of the certificate, there are certificate attributes, which is the CN, the SAN, the OU, and the O. And usually they have data like this. So this is SSL.com, and you can see inside of this certificate, they also have references to other DNS names in the SAN section. So answers.ssl.com, faq.ssl.com, info, links, reseller, secure, et cetera, et cetera, et cetera, et cetera. So what we have to do is we have to scan the whole cloud range, which is not trivial, and pull down every certificate and look in every one of these fields for our target to find out what they have online. So some previous work in this area was Zero, and we loved this tool. Problem is it's not currently really maintained up to date, and it didn't fit all of our use cases. We want to be able to do this really, really, really quickly to catch those ephemeral assets. With our tool, you could run multiple instances of it, and it could tell you for any one given company, basically, every 5 minutes if something pops up on the internet. So, okay. Other work in this area was this hacker group called Käferjäger.gay. They didn't release any tooling, but they did release this website that you go and they would scan all SSL certificates and dump all of the output of their tooling to these folders, and you could just download the files and then parse them with grep, right? And so this was good. Some other things in this area you could think of as Shodan handles looking for certificates, and so does cert.sh, but they all have drawbacks. So we'll talk about the drawbacks kind of at the end. Okay, so today we're releasing CloudRecon. The repo should be up, right? Mm-hmm. Repo should be up, and I think Gunnar is gonna give us a go. Actually, we have a recorded one, and then we're gonna do a live one too?
Yep.
Okay, so we'll do the recorded one first. So this is CloudRecon. It's built into 3 modules, so scrape, store, and retrieve. And here you can just give it CloudRecon scrape, and it'll take an IP range, or it'll take a file of IPs. So here is here's 2 IPs, and you can see we're getting the certificate metadata from those really quickly. Those were HackerOne's ranges. And now we're going to change it to store. We're going to store those in our DB to keep them for long-term storage so we can retrieve them later. And then we're going to use retrieve to grab all the data. I think.
Yes.
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 Yeah, there we go. Okay, cool. So it stores it in JSON output. And okay, so that's the recorded one. Do you want to do a live one real quick? We'll do a couple?
Absolutely.
Okay. So you have to pass the mic because they can hear through that, yeah.
Okay, so we're going to do state.gov as an example, because why not? But again, this can be done for anything. Similar to what Jason was talking about. So I actually ran the tool for this demo last night. I ran it against all of AWS, all of GCP, all of Azure Gov, all of Linode, all of DigitalOcean, some of Facebook, and some of OpenAI Space. And it ran in 2 hours and 20 minutes on port 443 on about a $30 DigitalOcean VPS. Okay, so that's the point of the scrape. The store version, where you're storing it to a local DB, obviously you can't do as much just because of connection pools to the DB, right? So you can't do a million. But the scrape version you can. And again, the tool is built in Go, so it uses the best memory management we could possibly do. So you don't need a whole bunch of RAM. It's all based on CPU. So you can use a CPU-purposed VPS, and you can scale it up as fast as you want to go, and you can scan away. I've not had an issue scaling it yet. I put it on a $400 box for a second, and it goes very fast. So here, again, it's just on like a DigitalOcean box. And all I'm going to do...
Can you make your text bigger? Control plus? Or
is it Control plus on a Mac?
Or maybe Apple plus?
Oh, no.
Command plus.
I thought it was Command plus. That's what I thought.
There you go.
Perfect. I knew that, by the way. I know how to use my computer. It's fine. Okay, so can you hold this for me?
I can. I will hold it right here.
Okay, so all we're going to do is I actually use, for my IP ranges, there's actually a repo. I think the guy's name is Lord Alfred. Shout out if you happen to be in the room. If not, great. But he keeps a repo of all the cloud ranges up to date, I'm pretty sure daily. So I went into here, into IP ranges, whoops, spelling. And in here, there's one called all, which basically just pulls them all together. And like I said, yesterday, I just used scrape and just dumped it in a text file. The text file is very big, but you can still just cat it into grep, and it runs fairly fast. And we can do state gov, like that, and we dump a lot of certificate data, right? So the output from scraping is greppable, obviously, like all the actual domains are within brackets and then just comma delimited. So you can do grep, sed, awk, whatever bash magic you want to do. If you don't want to use the store function and you just want to run it hyper fast and grep it, That's what the scrape function is basically for. It's for if you want to scale it up and just go pretty insane. But you can obviously basically do anything because it's text data. So you can basically you can look for IPs, you can look for, like I said, domain strings, you can look for anything like that. The store function is what we talked about, also grabs the organizational info, and you're allowed to query that by domains. The scraping is purely IP domain, but it's very fast.
So we use state.gov as an example because I was demoing this at RSA, this technique, and the head of the White House Cyber walked by and she was like, "Are you hacking state.gov like at RSA?" And I was like, "No, it's just Recon, doesn't count." And and so the first thing I did was I went out to find their networks, their ASN basically, right? That's the first thing I do in bug bounty or red team is go look at their ASN, and it pointed to it didn't have any data for them, right? It didn't tell me their IP ranges at all, and so then I went and did some other OSINT, and I found out that that they store most of their stuff in the cloud, right? So that's my workflow for a red team or bug bounty engagement, right? Check for the ASN information first. If you get IP ranges from that, you're going to port scan all that. And then also check, use some OSINT methods and see if they host anything in the cloud. And then if they do, you do this. You find all their stuff in their cloud. And that gives you a complete view of an organization, their own IP space and their cloud IP space. And then we went and presented to the White House, and they were like, "We didn't know we had a ton of this stuff online," which was kind of scary. So, okay. This is you.
Sure. So like we talked about, there are tools out there that either A, do something similar to this, or have similar data, especially. The two on the screen, obviously, are Shodan and cert.sh, are some that probably some folks know about. So we just want to talk about a few differences. We talked about Zero, and there are a couple other tools out there that do it. There are tools out there that do the same thing. This one I've had the most luck with scaling quite a bit. That's kind of, especially with the scrape module, that is really what we went for. It's like super large IP ranges, like the cloud, very fast, very efficiently. And again, like in the video demo, you can set timeouts. You can drop the timeout to like almost none, which will speed it up even more, and all that kind of stuff. But for Shodan, for instance, like yes, you can go get certificate information off Shodan, but again, you're kind of relying on Shodan then to figure out how up to date it is, and how truthful it is and all that kind of stuff, versus this basically puts the power in your hands to have it as up to date as you would like and on the specific assets you would like, right? So you don't have to like query Shodan, you don't have to pay for an API key. You go to my GitHub and you download it and you run it on whatever you want, and then you can have it. The thing with cert.sh, why we bring it up, is because CloudRecon does not care if the certificate is self-signed, if it's trusted or not, all that kind of stuff. Cert.sh grabs out of certificate authorities. We do not. We don't care who signed it or who wrote it. All we care about is what's in it. So it pulls everything. And you can use this, as in the video, there's a -P, a port flag. So if you want to use other TLS that you think might also be hosting TLS certs, you can do that. Anything that uses TLS, it will hit. The other benefits over some of these other tools is the likeliness that you get in trouble for port scanning everyone's crap is very low, because all it is a TLS handshake. You are not actually port scanning. You are sending someone a TLS handshake, and if TLS is not on that port, whether it's down or whether it's running a different service, the packet is just dropped. You are not connecting to someone's port unless there's a TLS handshake to be had, in which case you're doing the TLS handshake, getting the certificate back, disconnecting, and going about your way, right? So it's very fast, it's very efficient, and as far as like intrusive recon goes, it's very lightweight. So that's some of the benefits over some of the other stuff you might see out there. Yeah.
So one of the things that we had was, as part of the red team engagements I'm a part of, we used K4Jaeger, which was kind of the most up-to-date repo of this certificate data. There used to be another one called bufferoverflow.run by Irby Sam, but they discontinued that. So I was using the text files for a long time until Gunnar and I hashed this out. But the problem was they were only scanning every month, right? And so their text files were old by the time I got them, and then Shodan and cert.sh don't give everything, and you have to pay for them. You can exhaust your API really quickly. As a red teamer, I want all of this power on my own box. I don't want anyone to take it away from me, and this is the fastest thing I've ever seen as far as it goes for this method. So we tried to put a lot of work into that. We also, do we want to talk about the thing where sometimes you have to multiple request SSL to actually like see that it's up?
Oh yeah. So some things like to basically disappear and reappear. similar to the ephemeral assets conversation, having the power to scan in your own thing and having the power to set timeouts and stuff like that, there are some things that you may have to wait 3 seconds for instead of 2 or 1 for the handshake to actually complete, right? Some of the other tooling, stuff that uses like either some like weird or like slower version of TLS, or it's just like running slow, or that, you know, there's a lot of route hops, will either not show up or be false negatives or that kind of thing. So the tool really allows you, depending on what you're scanning and the infrastructure you're scanning and how wide you're scanning, you can either be very thorough, or you can be very fast, or you can mix and match. Because you're going to see a lot of different stuff out there that reacts very differently. And this allows you to catch as much of that as possible, where some of the other stuff, you just kind of assume. The other big thing too that I forgot to mention, it was my turn with the mic, is giving this to you means that if Shodan suddenly goes off the internet tomorrow, you know, hope is not lost type of a thing. That's kind of the goal of putting this on your box, like Jason said, is now you don't have to rely on someone else's stuff, whether it's right, whether it accidentally goes away, whether they go down, whatever it may be. So, yeah.
One more use case is if you're on an internal pen test, so you can give it ranges, right? And so if you're on an internal pen test and you want to find all of the websites that use SSL in an internal network, you give it your client's internal ranges, and it'll go find that without doing a port scan. Not many of them are monitoring at the SOC level just SSL connections. They're monitoring full port scans with all their tools, but this bypasses a lot of that type of stuff. So, cool. Well, it was pretty short. You guys want to run some domains? Anybody want a domain we can run it against?
Oh, I had a question.
Oh, yes. Question, yes.
Sorry, but you already covered this. But is it only connecting on 443, or can you specify?
You can specify which port. Yeah,
Yep.
so 8443, 443, 4333, whatever some wonky port somebody's doing for SSL. Yes?
Quick question. You guys are scanning IPs, correct? How are you guys approaching identifying ephemeral assets that are behind like a reverse proxy? Like specific, like subdomain or something?
Can you repeat the question?
I'll repeat it. We have to repeat the questions. I can answer that too.
Go
I
ahead.
know.
Yeah.
So you're asking, if I'm correct, how we are identifying ephemeral assets that may be behind reverse proxies by just scanning IPs?
Yeah.
So that is part of it, is because a lot of times those reverse proxies in the subject alternative names of the certificate will have the domain of the domain they're proxying for. So that's normally how you would catch those. That's basically what it would have to do, right? Because it's only parsing certificate data. So if you hit a reverse proxy that's reverse proxying for some ephemeral asset or just any type of asset, sometimes those domains do come bundled into the certificate with it, and that's how you would catch it. I've looked through it. If you want to run it yourself and type in like .internal, you find a lot of interesting stuff.
Yeah. A lot of times companies will also they will also bundle one cert for like internal and external assets and just sign it once. And so, like he said, like you can grep for internal and your target's name, or like there's just a lot of stuff. Even in the example we just did, I think we saw a couple dev, like state.gov stuff. There was a couple dev sites and stuff in that list. So, yeah.
What's wrong?
Put the URL slide.
Oh, the URL slide.
Wait, which one?
Which slide?
For CloudRecon.
Oh, I can.
Oh, yeah, go to the repo.
Yeah, I was going to pull up the repo.
Oh,
Yeah.
Yep.
Question? I think there's one back there. Yeah.
Yeah, that was actually my question. There's a couple of CloudRecon tools on GitHub. Which one specifically?
Oh, there's-
Yeah, this is called CloudRecon, and we will go to the repo right now. Sorry, we have a bunch of tools we're releasing today.
But we can't read.
Yeah, there you go. So it is GoldenSec. You can't make the, there's CloudRecon. So, any other questions? Yes, sir.
So, adding to the question about finding things behind reverse proxies, could this be used to also identify origin servers on Cloudflare?
Absolutely. Sometimes they sign their origin server with the cert and then put it in the SAN, and then you're like, oh, why does that say origin? And then you just go directly to it, or if it's virtually hosted somehow, you add the host header, and you visit it, and you can find the origin and bypass all WAFs, basically.
That saves me so much time.
Yes, it's amazing. It's how I exploit most SQL injection, so yeah. Question? Yes?
So are you able to avoid like rate limiting and things like that from AWS as a whole because you're only hitting?
Correct.
Yep.
The question was, are we able to avoid rate limiting because we're only doing the SSL connection? Yes, we are.
I have a good answer for that.
And he's got more.
So when I ran it last night, Again, it finished in like a little over 2 hours for all that stuff. I didn't use over 800 megabits per second of network traffic, which is pretty low nowadays. So yeah, you normally don't, it doesn't blow anybody up. It doesn't even blow, like, it is literally something if you did have a bunch of hardware sitting in your house, like your ISP won't even hate you. You would like really have to try hard.
The other thing is that with a single run, you can do it in 2 hours. If you're running concurrently this tool and you break up the IP ranges a little bit to each box, you could have a fleet of servers running CloudRecon and literally tell you about your target every 1 minute that it brings new stuff online. And it's not that expensive. So, any other questions? Yes? Is SNI supported? Yes, I believe it is. Yes. Come talk to me after. We based some of the code off of Zero, which was handling SNI. So come talk to me after. I'll give you a more detailed explanation. So yes. Question behind that gentleman. There was one back there. You? No? Okay, good. Anyone else? Great.
Thank you.
Thank you so much.